Good morning, Stingrays. Today is January 19th, ladies and gentlemen. That's Tuesday. That's school day. That's why we're here. In case you haven't heard, they have officially made the word that we will be going full remote, which is what we've been doing for everything but those 3 weeks, till the end of February now. Okay, till the end of February. So the new date is March 1st is the new date, or March 3rd, I think. Go to the first and the second or a weekend. But we move along. Okay, we're heading into our last section for chapter 4, which is all about similar figures. Okay, now what that is it's seeing ratios and it's seeing proportions in a different way. Okay, I'm not straight up giving you a ratio or a proportion. You get these figures, you get these little shapes, and your first task will be to figure out if these are proportionate. Okay, is this just a smaller version of this? We're going to use ratios and proportions to figure that out. Okay, so same thing over here. Is this just a smaller version of this? Okay, how do we do that, you ask? Well, you have to know what sides match with what. That's the most important part. Over here, it's going to be easy because the shapes are the same thing. Over here, it's not. The shape is slightly turned compared to that one. So let's go over. Let's get some colors involved. As you can see, this is the long side of the triangle. Okay, so this is the long side of this triangle. We're going to set up a proportion. We have to actually make the proportion this time. Okay, so let's make the proportion. So equal sign. Let's do this. Choose black for the equal parts. Equal. Okay, so remember, a proportion is an equation stating that two ratios are equal. Okay, so an equation means it has an equal sign. Whatever you put these two, they have to match. So if you decide to put 21 on the top, 7 has to go on top. If you decide to put 21 on the bottom, 7 has to go on the bottom, because they are essentially like when you have word problems with proportions, they're the same unit. Okay, they're like the same units, and the same unit has to be on the same level. These are the same side, they have to be on the same side. So 21 and 7, we'll use the bottom, because it tends to be the bigger number. So 21 and 7. Now, as you can see, 6, 5, 18, 15, they're not the same numbers. Okay, they're not the same numbers. So you have to make sure you're matching up the correct ones. Let's go with the left-sided one. Okay, the left-sided one. I'll circle it in green. Can you see that that's green? Somewhat. So I circled it, it's green, because it is the left side of the equation. So I want to make sure that I'm keeping it on the left side. I can't do left side up here and right side over here. It's not the same side. It has to be the same side. Okay? Has to be the same side when it's here. So let's do that. We have 18 and 6. 18, 6. Now I have my proportion. I've made a proportion. The question is, I'm going to use this to find out if it is indeed proportionate. You can't really see that 6. Let me make it a little better. 6. There you go. 6. So, from last week, and maybe even the week before that, how do we check to see if it's proportionate? If what is it called? This is a ratio. We make it into a proportion? Yeah. So how do we know if this shape is indeed proportionate? We set up a proportion, which is an equation stating that two ratios are equal. Let's cross multiply. Cross multiply to see if it's true. Don't be afraid, okay? Calculators are being used for this section. I'm okay with that. So we have to cross multiply. We're going to cross multiply. 21 times 6 equals 126. Okay, always multiply up. Now cross multiply the other way, multiplying up. 18 times 7, 126. So 126 over here, 126 over here. These two shapes are indeed proportionate. I'm going to go real fast through the next one. Okay, so once again, this one's pretty easy because you have the same side. The same side is pretty obvious. Okay, so let's set up our equation. Make sure we put the same side on the same part, top or bottom. Can't crisscross. 8 and 8, 14 and 14. That makes it easy on us. 8 goes there, 14 goes there. Cross multiply, cross multiply. 6 times 14 is 84. Okay, now what's 8 times 12? 96. So are these similar shapes? Is this proportionate? Is this shape proportionate to that shape? The answer is no. Okay, answer over here is yes. Yes and no. Simple as that. Okay, that's the first step. Okay, when you get your worksheet, when you do your small group worksheet, there's a whole page on that. Then there's a whole page on what I'm about to set up right now. Okay, so chill. Okay, we're back. So now they're not asking you if they are proportionate. They're saying what makes this proportionate. Okay, you're tasked with finding the x. Okay, making the statement true. So we still do the same thing. We are still using proportions, which is an equation, to find out if the ratios are indeed equal. So let's look at our first problem. This one, I like this one. I like to start with this one because it's not the same. These are exactly the same, just shrunken. These are the same and twisted. Okay, so long side here is 36. Long side here is, oh, that's our x. Okay, that's fine. So it has to match because the long side is 36 here. The long side is x. It has to be on the same side of the equation, up or the down. Okay, so now we have 30 and 25. 30 and 25. This looks just like what we did last week, what we spent all week on last week. Simply put, there's a two-step process for solving proportions. What is it? Step 1, cross multiply. Step 2, divide. Thank you. So let's do that right now. 36 times 25 equals, 36 times 25 equals 900. Big number, big number. All right, 900 then gets divided by the number that's all by itself, the number that would have been cross multiplied with the x. So divided by 30 gives us an answer of, ironically, 30. Now, Mr. Nugent, how could that be 30 if this one's 30? They both match. They don't match. Remember, the matching sides are the ones that are on the top and the bottom. Okay? So, in this equation, x equals 30 is your answer. Okay? Last problem. Last problem, then I'm done. Clear some space. Now, this one's a little easier because the sides are matching. It is not twisted, it is not turned, it is simply shown to you. So, it doesn't, let's just, 21 and 15, that's the ratio here. Okay, that's the ratio here. Because this one is 25, that side's 15. You're taking those two sides and you're making a ratio. See what we did here? And since you put an equal sign between the two ratios, that makes it a proportion. Because that's what you're trying to find out, is it proportionate in the previous ones? Yes, it was. I'm telling you these are proportionate, and I'm asking you what is this number when it's proportionate? All right, the x is on the same side as the 21, so the x must be on the bottom? No, must be on the top. Because the 21 is on the top, the x is on the top. 35. The two-step process for solving proportions. Cross multiply, divide. Cross multiply, divide. Cross multiply, divide. Cross multiply, divide. Multiply, divide. 21 times 35. This time it's 21 times 35 is 735. And divide that by the number that's all by itself, 15. And I'm going to get an answer of x equals 49. They're not different. They're not different than solving proportions. It's just you have to use now this image to set up the proportion. Okay, it's kind of like getting a word problem with no words. You want to think of it that way. All right, there's a test on Friday on chapter 4. Ratios are proportionate. Are these two ratios proportionate? Solving a proportion, similar figures. Okay, I'm probably going to be doing I'll most likely be doing a chapter review on Thursday. Yeah, some of you still need to finish your iReady diagnostic, so you'll be finding time to wedge that in this week. But yeah, I got a lot of editing to do. Don't forget, like and subscribe.